Have you ever looked at a rocket launch and thought, how does this massive metal structure actually escape Earth? I mean, Earth's gravity has been holding oceans, mountains, and us down for billions of years, so how does a spaceship break free? The answer lies in a mix of physics, engineering, and some seriously controlled explosions. Let's start with the biggest problem, gravity. Earth pulls everything toward its center with a force of about 9.8 meters per second squared. To escape this pull, a spaceship must reach an incredible speed called escape velocity, which is roughly 11.2 kilometers per second. That's around 40,000 kilometers per hour, faster than a bullet, faster than any airplane. This is why spaceships can't just fly upward like planes, they need rockets. Now comes the key principle that makes rockets work. Newton's third law of motion: for every action, there is an equal and opposite reaction. Inside a rocket, fuel burns and produces hot gases. These gases are forced out of the rocket nozzle at extremely high speeds. When gases shoot downward, the rocket is pushed upward. No air is needed for this, which is why rockets work even in the vacuum of space. But burning fuel isn't enough. The rocket must be carefully designed to survive insane conditions. At launch, engines generate temperatures hotter than lava, and the rocket experiences vibrations strong enough to shake buildings kilometers away. That's why spacecraft are made using lightweight but ultra-strong materials like aluminum alloys, titanium, and carbon composites. Strong enough to handle stress, but light enough so gravity doesn't win. Weight is such a big enemy that rockets are built in stages. As fuel in one stage is used up, that empty section is dropped off. This reduces mass, allowing the remaining rocket to accelerate faster. Think of it like throwing away a heavy backpack mid-sprint, you instantly move faster. Without staging, reaching space would be nearly impossible. As the spaceship climbs higher, it faces another challenge: atmospheric friction. Air resistance heats the rocket's surface due to friction, especially during re-entry. That's why spacecraft use heat shields, often made of special ceramic materials that absorb and dissipate heat instead of letting it destroy the vehicle. These shields literally burn away layer by layer to protect what's inside. Once the rocket reaches space, something interesting happens. There's almost no gravity pulling it down the same way we feel on Earth. Astronauts float, not because gravity disappears, but because they're constantly falling around Earth in orbit. The spaceship moves forward so fast that it keeps missing the planet as it falls, creating continuous free fall. That's orbit. But reaching orbit is only part of the mission. Spaceships need precise navigation systems. Computers calculate position, speed, and direction using gyroscopes, star trackers, and sensors. Even a tiny error can send a spacecraft millions of kilometers off course. Space doesn't forgive mistakes. Life support is another critical factor. In space, there's no oxygen, no pressure, and extreme temperatures. Spacecraft must carry oxygen, remove carbon dioxide, regulate temperature, and shield astronauts from radiation. Every breath taken in space is engineered. So when a spaceship finally reaches outer space, it's not just brute force, it's physics perfectly applied. Gravity is challenged with speed. Motion is controlled using Newton's laws. Materials are chosen down to the atom. And every launch is a balance between power and precision. The next time you see a rocket lift off, remember, it's not just flying upward. It's fighting gravity, shedding weight, surviving fire, and obeying the laws of the universe, one equation at a time. If this video helped you see space travel differently, hit the like button, it really helps the channel. Subscribe for more real-life science explained simply, because the universe is full of questions, and we're just getting started. Until next time, keep questioning, keep learning, and keep looking up.